Welcome to solverfy.
We are asked to complete an argument that was started earlier in example 3. So, all that, we split the vertices into two groups. One group M contains the vertices V1, V2, and V3. And another group N contains the vertices V4, V5, and V6. Now we showed that if V3 was in R2, then the graph K33 could not be planar. Where of course R2 is the region within the cycle C4 with vertices V1, V2, V4, and V5. And R1 is the region outside the cycle C4. So when I say element, I really mean V3 is inside this region. So we want to prove now that K33 is not planar when it's in R1. These are the only two possibilities for V3. So now let's suppose that V3 is inside of R1 instead. Well, then it follows that the region R1 is divided into two subregions, R11 and R12. And I'll draw these in a picture. So we have vertices 1, 2, 4, 5, and 3. And we have edges form a sort of square here. And a triangle. And we see that inside this cycle, this is R2, and now we divided R1 into two subregions, R11 and R12, where R11 lies inside the cycle V1, V4, V3, V5. Now, we still haven't placed V6, so V6 has to be placed in one of these regions and still be connected to V1, V2, and V3. So suppose that B6 is inside of R11. Then it follows that the edge V2, V6 need to cross the edges V1, V4, or V1, V5. So it can't be inside of R11. Well, if it is, alright, now suppose that B6 is in R12. Well, then we have that the edge V16 will have to cross V3, V5, or V3, V4, or V2, V4, or V2, V5. Finally, let's suppose that B6 is inside of R2. Then it follows the edge V3, V6 need to cross V1, V4, or V1, V5. And so it follows that it's not possible to draw a graph and place the vertex V6 in one of the three regions so that V6 is connected to V1, V2, and V3 without crossing any of their edges. So it follows that the graph K33 is not planar.